Hello and welcome back to Zuluwa Consultants. In this video, we want to look at this question, which is demanding us to find the molecular mass of this sample. So the sample contains 49.48% of carbon, 5.15% of hydrogen, 28.87% of nitrogen, and 16.49% of oxygen. So let's see how we solve or how we determine the molecular formula of this sample. Now, before you can determine the molecular formula, the first thing you need to do is to determine the empirical formula of this sample. And the percentages which we have been given, these are the percentages by mass. So let's then convert these percentages to the mass. So we are saying the mass as the first step, we have carbon, and then we have hydrogen, we have nitrogen and oxygen. So the mass for carbon, it is saying it is 49.48 grams. Then the mass for hydrogen, it is 5.15 grams. Then the mass for nitrogen, it is 28.87 grams. Then the mass for oxygen, it is 16.49 grams. So what we have basically done is we have converted the percentage that we have, because this is the percentage by mass. So we have changed them into mass. After changing them into mass, we need to find the number of moles for each of the elements involved in this sample. So how do we calculate the number of moles? We are saying number of moles is equal to the mass divided by the relative atomic mass of each element in the sample. So let's start with the first one, which is carbon. We have the mass is 49.48. We are dividing this with the relative atomic mass, which is 12 for carbon. Then we go to hydrogen, we have 5.15. The relative atomic mass of hydrogen is 1. Then we have 28.87. The relative atomic mass of nitrogen is 14. Then the last but not the least, we have 16.49. The relative atomic mass of oxygen is 16. So here we want to find the number of moles for each. So let's find the number of moles for each. We'll start with the one, that is the first one, carbon. 49.48 divided by 12. We are getting 4.12. And then 1 into 5.15, we'll get 5.15. And then 28.87 divided by 14, we are getting 2.06. And then 16.49 divided by 16, we are getting 1.03. So these are the number of moles of each element that is in this sample. Now, after finding the number of moles, we divide this number of moles with the smallest mole. So when you look at the smallest mole, so the smallest is this one. So we are saying all of them will be divided by this number. So we are saying 4.12 divided by 1.03, then 5.15 divided by 1.03, and 2.06 divided by 1.03, then last 1.03 divided by 1.03. So here we can start, that is 4.12 divided by 1.03, we are getting 4, and then 5.15 divided by 1.03, we are getting 5, and then 0.36 divided by 1.03, we are getting 2, then this other one we are getting 1 there. So these are the mole ratios that each of the element has. So this simply means we have C4, and then H5, then N2, and O. So this is the empirical formula. We have managed to find the empirical formula here. Now the question is continuing and requesting us to find the molecular formula. For us to find the molecular formula, we say X, open bracket, the molar mass of the empirical formula should be equal to the molar mass of the molecular formula. So we need to have the molar mass of the empirical formula. The molar mass of the molecular formula we already have. We have been given here. This is the molar mass of the molecular formula. Now the empirical formula that we have is here. So let's calculate it here. We have C4 there, H5, N2O. So this is 1 atom multiplied by 16. This one is 2 atoms multiplied by 14. This one is 5 atoms multiplied by 1. And this one is 4 atoms multiplied by 12. So these are the numbers from the periodic table. That is the atomic masses of each element there. Now we have, for this one we have 16 there. Then for this one, 2 times 14, it is 28. Then this one is 5. Then this one is 48 there. So we can calculate the total there. 48 plus 5 plus 28 plus 16. It is giving us 97 grams per mole. So this is the molar mass of the empirical formula. So we are saying X, then we put the molar mass of the empirical formula, which is 97, close bracket, is equal to the molar mass of the molecular formula, which is 194.2. So at this point, we can now calculate or find the value of X. So the value of X is equal to 194.2 divided by 97. So 194.2 divided by 97, it is giving us the value of X of 2. So this is the ratio that we should multiply the empirical formula to find the molecular formula. So we are saying we have two open brackets, C4H5N2O. This will give us the molecular formula of C8H10, then N4 and O2. So this is the molecular formula that we need to find. Hope you have followed and enjoyed this video. Until next time, it is bye-bye.